Imagine finding out that the secret to becoming, like, a fundamentally better problem solver isn't found in some massive textbook or a TED Talk,
Right.
but it's actually hidden inside entry number 183 of a programmer's daily work diary.
Yeah, sounds crazy, but it's true.
It is. So today, we are zooming all the way in on this micro case study and how we interact with the tools we use.
Mm-hmm.
And we have a single, highly specific source for this deep dive. It's a technical diary entry written by a programmer named Ang.
Right.
It was published on July 10th, 2026, and the title tells you exactly what kind of granular journey we're going on today.
Oh, yeah, it really does.
It's called Notes-on-Haskell-Programming, Part 183, Bypassing Hspec's -- rerun config.
And I mean, just reaching part 183 of any personal notes series points to a very methodical approach,
Yes,
to the daily grind of working with technology. Aang is doing something we rarely see documented out in the open.
Which is what? Exactly.
Well, they're logging the tiny, frustrating micro frictions of a normal Tuesday.
Right. Rather than waiting for some massive victory to blog about.
Exactly. And within a few short paragraphs, this text captures a complete narrative arc of trial, error, and realization about how to properly communicate with a machine.
Okay, let's unpack this. The core problem Aang was trying to solve is highly targeted, right?
Very targeted, yeah.
They were trying to force their testing tool, which is called Hspec, to run the entire test suite for their code.
Right, instead of just running the specific test that had failed on the previous attempt.
Exactly. That is the entire premise of the post. But to the average person, or even a casual tech enthusiast, this seems like an incredibly minor hiccup.
Yeah, a tiny configuration annoyance.
Right. A setting is being annoying, you figure it out, and you move on. So my first thought reading this was trying to figure out why Aang felt this specific tiny friction was worth an entire entry in their public notes.
Well, what's fascinating here is that this short text perfectly encapsulates a fundamental tension in systems design.
Okay, what kind of tension?
The tension between permanent configuration and temporary execution.
Oh, right.
Because in any complex workflow, whether that's software development or managing a corporate supply chain, micro inefficiencies compound rapidly.
Right, they stack up.
Exactly. If you have a slightly annoying workflow, a process that takes an extra 30 seconds and you have to repeat that process 50 times a day,
You're losing a lot of time.
suddenly you're losing hours of your week and draining your cognitive energy.
Yeah, that makes sense.
So documenting the shift from a clumsy brute force fix to an elegant fix is how developers refine their actual mental models.
They aren't just tweaking code.
No, they're actively evolving their understanding of how to bend a system to their will without breaking it.
Okay, so we need to set the stage for why this problem even existed for Aang in the first place.
Right, because it requires a quick look into the daily reality of modern software development.
Yeah, so when a developer is building an application in a language like Haskell, they don't just write the code and hope it works.
No, that would be a disaster.
Right. They write an entirely separate batch of code called a test suite.
Mm-hmm.
And its only job is to constantly double-check the main code. Every time you change a button or, update a database query, you run the test suite to make sure you didn't accidentally break something else.
Which works beautifully when the project is small.
Right.
But as a software project grows over months or years, that test suite just balloons.
Yeah, you get huge numbers of tests.
Exactly. You might end up with thousands of individual tests. Running all of them from start to finish might take 5 minutes, 10 minutes, or even half an hour.
Oh, wow. Half an hour just waiting.
Yeah. And if you're a developer trying to fix one specific bug, waiting 10 minutes every time you make a tiny tweak will completely destroy your momentum.
So the tools adapt. Hspec, the framework Aang is using, has this efficiency mechanism built right in.
Right. It's very smart.
You can configure it with a command called --rerun. And once that is set up, Hspec acts incredibly smart. If you run the whole test suite and 5 tests fail, the next time you hit the test button, Hspec only runs those 5 specific failures.
Because it assumes that's all you care about.
Exactly. It skips the thousands of tests that passed. It takes seconds instead of minutes.
It is a massive productivity boost. The tool is actively trying to save the developer's time by making an assumption like, hey, you only care about what is broken right now.
Right, but systems that make assumptions will inevitably run into edge cases where those assumptions are wrong.
Exactly. And in Aang's case, on July 10th, they hit one of those edge cases.
They needed to bypass that efficiency mechanism. They needed the entire test suite to run from scratch, but the system just stubbornly kept trying to only run the failures.
Right, which brings us to the first breadcrumb Aang left us. The initial attempt to force the tool to obey.
The blunt force approach.
Yes.
Let's look at that. Ang provides the visual evidence right in the diary entry, pasting the exact git diff.
Right. For those who don't know, a git diff is just a visual layout showing exactly what text a developer added or deleted in a file.
Exactly. So Ang physically opened up the configuration file for the testing tool, a file named .hspec, and went searching for the rule that was causing the problem.
Because that .hspec file is the permanent rulebook.
Right.
Like when Hspec wakes up and prepares to run, it reads that file to figure out its baseline operating procedure.
Yeah. And Ang found the rule. Right below a line that says --failure report.hspec failures, there was the command --rerun.
Right there in plain text.
Right. And Ang's first instinct was to just highlight that text and delete it.
Just wipe it out.
Yeah. In the notes, that --rerun line is just crossed out. The rule is physically gone.
Yeah.
And by deleting it, Ang successfully forced the system to run all the tests.
The immediate roadblock was cleared.
Exactly.
But getting the immediate roadblock cleared is the danger of the blunt force approach.
Right, because it works.
Yeah, it works, which tricks you into thinking it was a good idea.
Yeah.
It is the equivalent of taking a sledgehammer to a locked door because you left your keys inside.
Oh, that's a great way to put it.
Right. You gain access to the room, but you have destroyed the door. The immediate problem is solved, but the structural integrity of the environment is compromised.
This feels like wanting to deep clean your house just for today, but to do it, you permanently throw away your weekly chore schedule.
Exactly.
You get the deep clean done, but next week, you have absolutely no system in place to maintain the house.
Yeah.
You have completely sabotaged your future self for a temporary win today.
And that .hspec file is precisely that chore schedule. Ang notes in the entry, quote, "Little did I aware, this is not a practical solution if I want to reduce the time taken to rerun only failed tests."
Yeah, the trap became obvious almost immediately.
Right.
I can picture the exact moment of regret. Ang runs the full test suite, gets the result, goes back to writing code, and then hits a new bug.
Oh.
They want to just test that one new bug quickly. But because they took a sledgehammer to the .hspec file and deleted --rerun, the tool has forgotten how to be efficient.
It starts running all 1,000 tests again.
Right. The developer permanently handicapped the tool to get a one-off result.
And in software engineering, applying permanent solutions to temporary needs is the root cause of so much technical debt.
Oh, for sure.
You create future work and future waiting time just because you are impatient in the present moment.
Right.
A configuration file like .hspec is meant to hold your ideal everyday defaults. Editing it for a unique one-off scenario violates the purpose of having a configuration file in the first place.
Yeah, and Ang recognizes this flaw and realizes the rulebook needs to be restored to its original state.
Right.
The permanent rules cannot be the thing that changes. This leads to a tactical pivot in the diary entry. We watch the problem-solving strategy evolve.
Yes, moving to the next level.
Instead of trying to change the rules of the system, Ang attempts to manipulate the system's memory.
Which makes sense. If the referee's rulebook is locked, the next logical step is to see if you can trick the referee.
Exactly.
To understand how Ang did this, we have to look closely at how a computer program actually, remembers things between separate actions.
Ang looked back at that .hspec configuration file and paid closer attention to the line sitting right above the one they previously deleted.
The failure report line.
Yeah, it was the line that said --failure report.hspec failures. Ang realizes that in order for Hspec to know which tests failed last time, it has to write that information down somewhere. It uses a specific state file. That file is literally named .hspec failures. It serves as the system's external memory bank.
And state is one of the most critical concepts in computer science.
Oh, yeah.
Think of a busy restaurant kitchen. If the kitchen relies entirely on the chef's memories to know which tables have received appetizers and which haven't, chaos ensues.
Oh, yeah, absolute disaster.
Right. They need a system of state, the physical ticket rail. The tickets are the state.
Okay, I see.
They maintain the memory of what has happened and what needs to happen next. Hspec's --rerun command is basically the chef looking at the ticket rail.
Right.
It only works because it can read that .hspec failures file.
So, if the ticket rail is empty, the chef assumes they're starting a brand new shift.
Exactly.
If that .hspec failures file doesn't exist, the testing system has no memory of any previous failures.
None at all.
And with no memory of failures,
Yeah.
it reverts to its baseline behavior of running every single test from scratch.
Huh.
Which brings us to Ang's first, quote-unquote, better approach.
Right.
The command is documented clearly as rm.hspec failures.
Right. The rm command simply stands for remove. Ang manually deletes the memory file.
Here's where it gets really interesting. It's like the Men in Black neuralizer.
Haha.
You just flash the system, completely erase its memory of the failures, and Hspec wakes up thinking it's a brand new day.
Exactly.
It looks at the failure report, sees nothing, shrugs, and says, well, I guess I'll just run all of them.
Yep.
The config file is perfectly intact, the rules are untouched, but the behavior is completely changed.
And exploiting a system's reliance on state is incredibly common, you know. By intentionally removing the state, you force a hard reset.
Right, but I have to challenge this, though.
Okay, go for it.
Ang positions this as a step up, but looking at it practically, is it actually any better?
No.
Deleting a file every single time you want to run a full test requires you to break your workflow, open a terminal, type a destructive command, and then go back to testing.
True.
It is still a manual, repetitive action just to coax the system into doing what you want for one single run.
Yeah.
And worse, you're actively destroying the historical record.
Yeah, if we connect this to the bigger picture, your skepticism is completely warranted.
Okay, good.
Deleting the state file is an evolutionary step forward from changing the core configuration, but solely because it leaves the permanent rules intact.
Right, the chore schedule remains on the fridge.
Exactly.
Yeah.
But it is fundamentally a destructive approach to problem solving.
You are basically burning the kitchen tickets just to force the chef to ask the tables what they want again.
Precisely. Let's say Ang had 15 highly complex tests failing.
Okay.
They delete the .hspec failures file just to force a full test suite run to check something else. Halfway through that long run, Ang realizes they actually desperately needed to review those specific 15 failures to trace a bug.
Oh, no?
Yeah, that data is gone. The file was deleted.
Wow.
Ang now has to wait for the entire massive suite to finish running, maybe waiting 10 or 15 minutes just to regenerate that exact same list of failures.
Just to get back to where they started.
Right. State is valuable context. Destroying state to manipulate behavior is a blunt instrument. It's slightly more refined than editing the config, but still a blunt instrument.
So we have basically painted ourselves into a corner here.
Pretty much.
Modifying the permanent config file is bad because it ruins the system's future efficiency. Deleting the state file is also bad because it destroys valuable historical context and requires manual, repetitive deletion. Both approaches require damaging something, either the rules or the memory, to force a temporary result.
And the progression of this diary entry brings us right up to the edge of that frustration.
Yeah.
And then Ang reveals the hidden door out of the room. This is where we move past destruction entirely.
The elegant solution.
Yes.
Ang reveals the final alternative right at the end of the post. Instead of opening a text editor, instead of deleting memory files, Ang leaves the environment completely untouched.
Completely alone.
The solution is to explicitly tell the system what to do at the exact split-second moment of execution.
Right.
Ang documents passing a specific flag through the command line. Stack test test arguments, quote, -- all, quote.
Yeah, let's translate that syntax. Stack test is simply the command to wake up the testing tool.
Okay.
-- test arguments acts as a courier. It basically says, hey, take the very next instruction I give you and hand deliver it directly to Hspec. And that final piece, quote, -- all, quote, is the actual message being delivered. It is an explicit instruction to Hspec. It says, run the entire suite, ignore the configuration file for a moment, and ignore the memory file for a moment.
It is a stunningly simple command.
It really is.
I mean, we spent all this time agonizing over editing files and erasing memories, and the answer was just to pass a temporary note to the system at runtime.
Yeah.
I was trying to puzzle out why this specific flag is presented as the ultimate peak of this journey. Like, why does this tiny command line argument represent the quote-unquote right way to solve the problem?
Well, this raises an important question about the philosophy of how we interact with complex systems.
Okay.
And it comes down to the difference between subtraction and addition. Passing a broader scope, like that -- all flag, at runtime is the most elegant solution because it is purely additive.
Oh, doesn't take anything away from the environment.
Exactly. The first two approaches were based on removing things. Editing the .hspec file was subtractive. It took away the -- rerun rule. Deleting the .hspec failures file was destructive. It took away the system's memory. Both approaches demanded that the environment be broken or altered to yield a result.
But the runtime override damages absolutely nothing.
Nothing at all. The configuration file remains perfect. The memory file remains perfectly intact. The developer simply injects a temporary overriding priority for exactly one moment in time.
It's like having a programmable thermostat set to 70 degrees every day. You feel cold one afternoon.
Okay.
The blunt force approach is tearing the thermostat off the wall and rewiring it.
Ah, right.
The memory wipe approach is taking the batteries out so it resets to factory defaults. But the additive approach is just putting on a sweater.
Oh, I like that.
You temporarily override the environment's effect on you without breaking the underlying system that will still keep you comfortable tomorrow.
That's perfect, because as soon as that single test run powered by the all flag finishes, the override evaporates.
Right.
The system reverts back to its pristine default state seamlessly. The very next time Aang runs the test without that flag, the tool reads the config, sees the rerun rule, checks the memory, and efficiently runs only the failed tests.
Yeah, it's seamless.
The immediate goal was achieved with zero technical debt and zero loss of context.
So what does this all mean?
Well,
We started by questioning why a developer would spend the time to document a tiny configuration issue in their 183rd diary entry.
Right.
But mapping out this journey, we have essentially followed a masterclass in refining how we communicate our intentions to machines.
very true.
We navigated through three distinct philosophies of problem solving. First, the permanent config edit, a clumsy attempt that sacrificed long-term efficiency for a quick fix.
Right.
Then, the destructive memory wipe, which preserved the rules but sacrificed valuable historical context. And finally, the elegant temporary override, an additive solution that satisfied the immediate need without destabilizing the environment.
Engaging with the friction is the real lesson here. Aang could have quietly deleted that memory file every single day, letting the annoyance slowly drain their energy. But by documenting the friction, by actively wrestling with the why, they pushed through the clumsy solutions to find the optimal one.
And the way the entry concludes perfectly captures the reality of that daily grind.
It really does.
After dropping this refined, elegant solution to a hyper-specific problem, there is no grand pronouncement. There is no bragging. The final words are simply, "Till the next host." Yours truly, Aang.
A quiet acknowledgement that the work is never entirely finished.
Exactly. Tomorrow will bring a new problem, another blunt force attempt, another tactical pivot, and the search for another elegant solution.
Yeah.
It's just the methodical process of getting slightly better at what you do, one small entry at a time.
And you know, the principles Aang is grappling with here, permanence versus temporariness, destruction versus addition, they apply far beyond the terminal window of a software developer.
Oh, absolutely.
So as we wrap up today's exploration, think about your own daily habits and workflows outside of programming. How often do you permanently alter your environment or your routines, essentially editing your life's config file to solve a one-off temporary problem when all you really needed was to pass a temporary override flag for the day?